Sets Venn diagram. Union of two sets. Union of two sets A union B, the set containing all the elements of set A and or set B, or both. A union B is equal to X such that X belongs to A or X belongs to B. That means the element which is in X as well as in B will consider in union of A and B. So here we can say in Venn diagram, U is a universal set, set A and set B. All the elements of set A and all the elements of set B will be considered in A union B, but repetition of the elements is not required. Here we can say, for example, set A has 1, 2, 5, 9, 11 and set B has the element as 2, 5, 3, 7, 8. Then A union B is 1, 2, 3, 5, 7, 8, 9, 11. Repetition of the element is not there, and we consider all the elements of set A as well as in elements of set B. Intersection of two sets, A intersection B, the set containing the common elements of set A and set B. So A intersection B gives that X such that X belongs to A and X belongs to B. Then for example, set A has the element 1, 2, 3, 4, 5 and set B has the element as 3, 5, 7, 8. Then the intersection means the common of element of A and B, that is 3 and 5. And the Venn diagram represent U is a universal set A and set B. The common shaded portion is implies A intersection B. Disjoint sets. Disjoint sets means their intersection is 5. That means there is no common element between set A and set B. For example, set A has an element 1, 2, 3 and set B has an element A, B, C. There is no common element, so therefore their intersection is 5. And by Venn diagram, we can represent the disjoint set as U is a universal set A all alone and set B all along. There is no common shaded region, so it is no common point, no common element is there in disjoint sets. Difference of sets. Let A and B be the two sets. Then A minus B, the difference of two sets, A minus B is the set consisting all the elements of A, all the elements which belongs to A but does not belongs to B. So we have A minus B, X such that X belongs to A and X does not belongs to B. Or vice versa, if I have to take the difference of B minus A, then we say X such that X belongs to B and X does not belongs to A. For example, we have an element, we have a set A as 1, 2, 3, 4, 5, elements 1, 2, 3, 4, 5 and set B has 1, 3, 5, 7, 9. Then A minus B, I will write all the elements of A excluding the common elements of B. So here 1, 3, 5, 1, 3, 5 are in set A as well in set B. So I will write only 2 and 4 and I exclude the common element 1, 3, 5 which are in A and B. Similarly in B minus A, if I have to consider B minus A, my main set is B. I will exclude the elements of A from B. So 1, 3, 5 is common between them. I exclude them, and the remaining element 7, 9 will come in the set B minus A. By Venn diagram, if I have to show that union set A and set B, U is a universal set, and set A and set B, I will shade only the elements of set A and exclude the common region of A and B also. So this is A minus B. Similarly, when we have to go with the B minus A, I have to show Venn diagram of the difference of B minus A. Then U is a universal set, A is a set, B is a set. I will shade only the elements which are in B, not the common elements. So common shaded region will not be included. Only the elements which are in B, that will be the difference of two set, B minus A. Complement of set. A complement is equal to X belongs to universal set and it does not belongs to A. If U is a universal set and A is a set, we consider all the elements of universal set except the elements of A. That the shaded region is the complement of set A. De Morgan's law says that if A and B are the two subsets of a universal set U, then A union B complement is equal to A complement intersection B complement. Or we can say A intersection B complement is equal to A complement union B complement. So let us proceed with the problem part. It says if A is a set X such that X is a natural number, X is greater than 1 and less than equal to 6. Then in roster form I will write A as 2, 3, 4, 5, 6. As x is strictly greater than 1 and less than equal to 6. So 6 will be included and a1 will not be included. So I have 2, 3, 4, 5, 6. B is a set x such that x is a natural number and x is strictly greater than 6 and strictly less than 10. So in roster form, I will write it here as 7, 8, 9. The elements of B are 7, 8, 9. So let us observe A union B. As we know that A union B means all elements of A and all elements of B. So in this case, I will write it here as set 2, 3, 4, 5, 6, 7, 8, 9. All the elements of A and B in A union B. A intersection B means the common elements of A and B. Observe it very carefully. We didn't find any common element between A and B, so therefore their intersection is 5. Empty set 5. A minus B. A is the biggest set and the common element will be excluded from set A. But here we didn't find any common element, so A minus B is the set A itself. So I will write it here as 2, 3, 4, 5, 6. This implies that the set A itself. B minus A, we exclude the common elements of A and B from the set B. But here we already shown that there is no common element between B and A. So B minus A is the set B itself. So I will write it here as 7, 8, 9, which implies set B itself. B minus A is set B itself. If U is a universal set containing the element as 1, 2, 3, 4, 5, 6, 7, 8 and A is a set having elements 1, 2, 3, 5, 6, B is a set having elements 2, 3, 4, 7, 8, then find A intersection B complement. B complement is the elements other than the elements in B. So first of all, I will write it here as B complement, which is equal to, if I compare with the universal set, I will get 1, 2, 3, 4 is there, 5, 6, 7, 8 is there. B complement is 1, 3, 5 and A is there. We have to find A intersection B complement. Then A intersection B complement. The intersection between A and its complement. The common element is 1 and 5, 6. So I have 1, 5, 6. A intersection B complement is 1, 5, 6. Then A union B complement. First of all, I calculate the A union B and then I will find A union B complement. So in this case, A union B is all the elements of A as well as B. Repeated elements we won't write. So I will write 1, 2, 3, 4, 5, 6, 7, 8. I observed that 1, 2, 3, 4, 5, 6, 7, 8 is same as a universal set. And whenever we have to calculate the complement, we take the complement with respect to the universal set. And here, with respect to the universal set, we have A union B complement as 5. Because this is my A union B. This is A union B. And A union B complement is 5 because A union B is equal to the universal set. So its complement of universal set is 5. A complement intersection B complement. Okay, calculate for A complement. A complement will be, comparing with this, I have 4, 7 and 8. A complement I have calculated. B complement I have already calculated. So I have to take the intersection of A complement and B complement. Then A complement intersection B complement will be common elements in these two sets. Nothing. Empty set or 5. A minus B complement. I exclude the elements of B from A set. So first of all, I calculate A minus B, which is equal to 1, 2, 3. I neglect 2, 3 because 2, 3 is there in set B also. And I will write 5, 6. And then I will write A minus B complement. A minus B complement means I will compare this set with the universal set. So I will compare with this. I get 2, 3, 4, 7, 8. So A minus B complement is 2, 3, 4, 7. Observe the Venn diagram and find the sets. Venn diagram, universal set is given to you. Some elements are in set A and some elements are in set B. We have to find A union B. A union B means that all the elements of set A as well as B. So here I will write C. 1, 2, 4, 7 are in set A. I will write here as 1, 2, 4, 7. And in set B, 0, 3, 8, 0, 3, 8. 1, 7 is also there, but I have already written 1, 7, so I will write only once. So this is the set of A union B. A intersection B, the elements, common elements of A and B. Here common elements I can easily observe 1 and 7 is only there. So 1 and 7 is the A intersection B. Next, A minus B. So our main set is A, and the common element of A and B, I will neglect that and I will get the remaining element of A. So this is my A set which contain the element 2, 4, 1, 7, but 1, 7 is also in set B. So I will take only 2 and 4. A minus B is 2 and 4 only. A intersection B complement. A intersection B I already calculated. Its complement means excluding 1 and 7, all the elements in this universal set will calculated as A intersection B complement. So all the elements here I will take 0, 2, 3, 4, 8, 5, 6, 9. 0, 2, 3, 4, 8, 5, 6, 9. All the elements except 1 and 7. Except 1 and 7 complement comes all the elements in A union A intersection B complement.